solving these equations. So if I wanted you to solve this first one, when you're solving an equation, you always have to get your variable by itself. So we need to, in this case, get our cosine by itself to start. So what would you do? Add your 1. And then what do we have to do? How do you get cosine by itself? How do you get rid of it? To get rid of the square root, we also have, or when we add a square root, we also have to put and square root of 1 is 1. You don't have very good friends.
No, I don't. Because I know the only one who got stuff.
Gus is the only one.
Yeah, no, I'm good. I'm good. Trust me, I got a bunch of
Because you know your friends will take things from you?
Gus.
Yeah, I know. I got these cheap pencils.
I give you a piece of paper every day.
Okay, so now let's look at our circle. Cosine, if you're looking at your unit circle, that's your x. When is that positive 1 or negative 1? Or is it positive 1 now? 2 pi. That's the same as 0, so you could list either one. And where is it negative 1? Okay, so my answers are pi and 2 pi, but I didn't give you a stopping point. You remember, sometimes when we did these, I would say, you know, between 0 and 2 pi. I said all possible solutions, and every time you go around the circle, you're going to come back and hit it again, right? So do you guys remember we had to put plus, how far is it to go around the circle? And if we're in radians, we would do 2 pi. And we can go as many times as we want, so we put plus 2 pi k, where k is an integer. Okay, so that means every time I go around that circle, I'm going to come back and hit that number again. Again, the only time you are going to have to put this plus 2 pi k is if I say all solutions. So how would I solve b? How do I have to get that by itself? And then we need to divide by 3. So tangent is negative radical 3 over 3. Okay, let's think through this. Remember, all students take calculus. So in quadrant 1, everything's positive. In quadrant 3, tangent is positive. So it would be negative in 2 and 4. Reference angle, when is tangent radical 3 over 3? So if you need to use your hand trick, remember tangent is square root of the top over square root of the bottom. So tangent of 0 is radical 0 over radical 4, which is 0. Tangent of 30, radical 1 over radical 3. Is that the same as radical 3 over 3? Yes. So that's at 30 degrees, which is pi over 6. So pi over 6 in quadrant 2, remember the numerator is 1 less, that's 5 pi over 6. In quadrant 4, that was double minus 1, so 11 pi over 6. And what do we put with each of these since I want all solutions?
Plus 2 pi.
Let's do one more. to solve this one between 0 and 2 pi. So between 0 and 2 pi tells me I don't have to do all possible solutions. So we don't need the plus 2 pi k there. First we have to get the sign by itself. I have it in 2 places, so what am I going to do? What's the very first review topic we did? That very first day we had a handout, you had to work with groups. Factoring. So let's factor. What can I pull out of here? Now we have 2 things to multiply that equal 0, so if I set each of them equals 0, okay, we're going to have several answers here. So on our unit circle, when is sine 0? So sine is the y. Y is 0 if you're at 0 or 180. So if we're in radians, 0 degrees is the same as 0 radians. 180 is pi. Bless you. Okay, negative 1/2. So sine is negative if we think all students take calculus. Everything's positive. Students' sine is positive. So it has to be in 3 or 4. Reference angle. When is sine 1/2? So if you think about your hand trick, sine is the square root of the figures above over 2. So it would be at 30 degrees or pi over 6. So in quadrant 3, pi over 6, numerator's 1 more, that would be 7 pi over 6. Quadrant 4, double minus 1 is 11 pi over 6. Any questions there? Okay, so that is the end of my examples. We have a couple things left to do for today. On the back of your trig handout, there is a set of 5 questions, so we're going to work through that in class today, just as some extra practice. If you were paying attention to the board, I would like to do a quiz tomorrow because we've kind of reviewed a lot of stuff already. We've talked about factoring, we've talked all about functions, and we've talked about all this trig stuff. So I'd like to do some quiz review as well. Which one do you guys want to do first? The trig handout or the quiz review?
Handout.
Handout? Okay. So everybody get out that packet I gave you. And let's take a look at this. So this is kind of a recap of everything we did from Friday and today in this trig section. Just a little more practice. As far as quiz review, so the homework and this will kind of suffice for your quiz review from the trig portion. So I won't do any extra of those problems when I review for our quiz. All right, if I have 315 degrees, how do we convert that into radians? Okay, when we do that, the degrees cancel, so we have 315 over 180. Remember, we do not want to multiply out the pi, so if you're using a calculator for homework, you could do that. Now, obviously, we talked about quizzes. We don't really want calculators. So I would give you easy ones, but this one's on our unit circle anyway. What does this turn into?
45.
It's a reference angle of 45, and 3/15 is in the fourth quadrant, so it's 7 pi over 4. Or if you did 3/15 over 180, it reduces to 7 over 4. So to convert into radians, you multiply by pi over 180. What if you want to go the other direction? I apologize, that's kind of blurry. It's 2 pi over 5. So what do we multiply there? 180 over pi. Think about the unit circle. Pi and 180 are at the same spot. They're equivalent. So then my pi's cancel. If I multiply, I get 360 over 5. So does that come out to be 72? 2/5 times 180. That's degrees. Okay, everybody's good on those? Three. I want you to evaluate all the trig functions here. So 3 and 5, I'll probably ask you quite a few questions on the quiz, like these. 3, I'm probably not going to say every single trig function, but I might ask you for a tangent of negative pi over 3 or something. That's the main part of this trig that we've got to be able to do throughout the year. So that'll be the majority of the trig questions I would ask you on a test or quiz. Do we usually deal with negatives? No. What do I do? Mm-hmm. Okay, so that's like 6 pi over 3 and negative 1 pi over 3, so that's 5 pi over 3. Now on test or quiz, I would ask you, what quadrant is 5 pi over 3 in? Sure. Reference angle in radians is, yeah, pi over 3, or if you need to, you can think that means 60 degrees. Okay, in Quadrant 4, all students take calculus. What's positive? Cosine and secant. So the other 4 will be negative. I'm just going to go ahead and throw a negative there so I know. And I don't forget it. Okay. Then 60 degrees. What is the sine of 60? So cosecant, you would flip that. You get negative 2 radical 3 over 3. Cosine is 60. That's the square root of the bottom over 2, so that would be radical 1 over 2, so 1/2, which means secant is 2. Tangent, square root of the top over square root of the bottom, so radical 3 over radical 1 is radical 3. Cotangent, if you flip that, 1 over radical 3 just turns into radical 3 over 3. And those are negative, we already said. questions there? Okay, why don't you guys try B? You can work. Okay. 7 pi over 6, what quadrant is that? And reference angle is? Right. Okay, so all students take, so tangent and cotangent would be positive. The other 4 will be negative. Okay, pi over 6 is like 30 degrees. So sine of 30, radical 1 over 2 is 1/2. So cosecant would be -2. Cosine, square root of the bottom over 2. So negative radical 3 over 2. Which means secant is -2 radical 3 over 3. Tangent, square root of the top over square root of the bottom, so radical 1 over radical 3 is radical 3 over 3. Cotangent, radical 3 over radical 1 is radical 1. So again, on the quiz, I'm not going to ask you to do all 6 for an angle, but I will ask you, what is the cosine of 7 pi over 6? I expect quadrant and reference angle when you do that. Okay, question 4. That's like what we just got done doing, so there might be 1 or 2 of those on there. These two are pretty straightforward. We don't even really have to get the sine or cosine by itself. I'm just asking you when sine is equal to -1. If you think about the unit circle, sine is your y. So if y is -1, we're here, and that is 270, so 3 pi over 2. I will ask for it in radians. I'm probably not going to make you do all possible, so you probably won't do the plus 2 pi k. I just want the original circle. Okay, cosine is radical 3 over 2. When is cosine positive? One and 4, so we have 2 answers. Reference angle. When is cosine radical 3 over 2? 30. Good. So in quadrant 1, pi over 6 is pi over 6. In quadrant 4, double the bottom, subtract 1, so 7 pi. Oops. 11 pi over 6. Okay. Number 5. Find each of these values. So the sine of 5 pi over 6. So there'll be these on the quiz. What quadrant is 5 pi over 6? Reference angle is pi over 6. In quadrant 2, all students, so sine is positive, and the sine of pi over 6, be radical 1 over 2, so 1/2. B, 4 pi over 3 is quadrant 3. Reference angle is pi over 3. So in quadrant 3, tangent's positive, that means cosine's negative. Pi over 3 is like 60, so cosine of 60 would be negative 1/2. Seven pi over 4, that's quadrant 4. Reference angle pi over 4. So in quadrant 4, cosine's positive, so tangent would be a negative. Pi Radical 4 is like 45, so tangent would be radical 2 over radical 2, which is questions. Unit circles, you know, if you need a blank unit circle, if that helps you in some way, you can always ask for it during the quiz. I have them available during Trig. I'm not going to change that now. So you could ask for it if you wanted one. All right, do you want to talk about what else will be on there? And then I'll stop here pretty quick and give you guys time to work on the homework. So the very first thing we did was factoring. That day one. So you know, if I gave you like (9x squared minus 100), how would you factor that? So 9x squared breaks into a 3x. One's positive, one's negative. And 100 breaks into 10. So I've got the quiz right in front of me, guys. I'm trying to go through everything that would be on there. So that's difference of squares. If we did something like let's say this. What would we do? So let's multiply to a negative 70, add to a negative 33. What would that be? Factor, we get 5x and 1, 2x and negative 5. So, probably throw a box method problem on there. We did some ugly ones that were really just a matter of greatest common factor, but they turned out kind of nasty. So let me make up one here. In this, I really just have two terms. So we have to look at what can come out of both. Remember on the ones we did, if we had a fraction, we just went ahead and pulled that out because it was a little uglier. So we're going to take out the 1/3. They both have a 2x plus 1. When you pull it out, you take out the smaller power, so that would just be to the first. And they both have x plus 3. We take it out to the smallest power, which, what's smaller, -4 or -3? Negative 4. Okay. Let's see what we have left. Took out the 1/3. I took out 2x plus 1 to the first. So when you factor it out, you subtract those exponents. So 2 minus 1 is just 1 remaining. took out all of this, so that's gone. Okay, we had 4, and I took out 1/3. When you factor out, it's like dividing. So 4 divided by 1/3. That means 4 times 3/1, so we just get 12. I took out the 2x plus 1. Okay, here, I took out -4. So when you factor it out, you subtract. So -3 minus -4 means -3 plus 4, which is just 1. So we just have 1x plus 3 remain. Yes?
So if you take out the fraction, you're still multiplying it to the other one?
Yeah, because you're dividing it, but if you,
Yeah.
to divide fractions, you always flip and multiply. All right, let's just see if we can clean this up at all. So this gives me a 2x plus 1 plus 12x plus 36. You will always need to check at this point. Sometimes this parenthesis that remains will have a greatest common factor. So if it were like 14x plus 36, I would expect you to go ahead and pull out another 2. But that one doesn't, so we're finished. Okay, so that's all the factoring. That's the nasty one. The other's pretty straightforward. Any questions there? I don't want to take up too much of our time reviewing. We talked about rationalizing. So if I said to rationalize this. Rationalize means get that radical off the bottom. So what do we have to do? You can distribute that if you want. You don't have to. I don't really care. So we -3 radical 2x minus 3. On the bottom, if we FOIL, we get square root of 2x squared, so that radical drops. Minus 1. Is that okay? In that section, we talked all about functions as well. So we talked about reading graphs, giving domain and range from a graph, finding the zero of a graph. The zero is the same thing as what? Yep, the roots where it hits the x-axis. Local minimums and maximums, so meaning highest and lowest points on your graph, not including those endpoints. Increasing and decreasing. Are we good with all that? Do I need to run through any of it? How much time do I have? We talked about like evaluating functions, domains. If I say give me the domain of this. If we have a fraction, what do we know about the bottom?
Can't be 0.
So x squared minus 4 cannot equal 0. Then what would I do? How do you get rid of a square? And if you add a square root, you need? X cannot be plus or minus 2. What if I said the square root of 5 minus x? Okay. If you have an even radical, so like a square root, what do you have to do with the thing underneath? It has to be positive. So 5 minus x has to be greater than or equal to 0. If I add over my x, 5 is greater than or equal to x. So that means x is less than or equal to 5. And remember, on those I did ask for interval notation. So that would be negative infinity to 5 with a bracket. We also did those word problems, which you guys did fine with. Just remember when you're writing those, which one is the y? When I say something is a function, the function one is the y. Okay. Would you guys like for me to hand back the homework from those couple sections if you want to look at any of it to see types of questions? And then you have that trig handout to work on. You've got the rest of the hour. I'm pretty sure that first day we did the factoring handout, and I didn't even grade that one, so you should have it still. And then I just have the topics B and C. So you've got a handout for each little piece. You're working on the topic